Have you ever really thought about the forces that run our universe? I mean, we're talking about everything from a magnet sticking to your fridge to the very core of the atoms that make us who we are. It sounds simple, but it hides one of the deepest truths about reality.
So let's just ask it straight up. What is the real difference between that pull you feel from a magnet and whatever is going on inside an atom? I mean, they both feel kind of invisible and mysterious, right? But as you're about to see, they are in completely different leagues.
Okay, so to really wrap our heads around this, we've got to start on familiar ground. Let's begin with a force we all pretty much get, one we can see and feel in our everyday lives.
And that is the electromagnetic force. Now, this is a big one. It's one of the 4 fundamental forces of nature. And you got to pay attention to that word, fundamental. It's like a basic, non-negotiable ingredient of the universe. It's the rulebook for how anything with an electric charge talks to anything else with an electric charge. And you see this force literally everywhere. It's that little zap of static electricity from a doorknob. It's why your hair stands on end. And yep, it's why a magnet snaps right onto your fridge. It follows these really predictable rules. But what's wild is its range. Theoretically, it's infinite. It can reach across the entire galaxy, even though, yeah, it gets super weak the farther out it goes.
All right, now, buckle up. We're going to shrink ourselves down. I'm talking way down. We're leaving behind the world we know and diving headfirst into the incredibly tiny and, let's be honest, super weird world inside a single atom.
And this is where we hit a massive puzzle. See, the center of an atom, the nucleus, is jam-packed with protons, and protons are all positively charged. Based on everything we just said about electromagnetism, well, they should want nothing to do with each other. They should be pushing apart and flying away with an unbelievable amount of force. So why don't they? What gives? What's the secret sauce holding it all together?
Well, the answer is what we call the atomic force. And the whole secret, the key to this entire puzzle, comes down to one single super important word: resultant. The atomic force isn't a fundamental force at all. Nope. It's the final outcome, the net effect of a bunch of other forces all duking it out in that tiny space.
It's this incredibly delicate but also incredibly powerful balancing act. You've got this constant tug of war going on. You have the electromagnetic force pulling the negative electrons in toward the positive nucleus, but at the same time, it's pushing those electrons away from each other. And then, deep down in the core, you have the crazy strong nuclear force that just completely overpowers that electromagnetic push, gluing all the protons and neutrons together. The atomic force, it's just the sum total of this entire chaotic dance.
So now we've got our 2 contenders on the table. One is a fundamental rule of the universe. The other is a complex local street fight. Let's put them head to head to really see what sets them apart. All right, let's lay it all out, side by side.
And wow, when you see it like this, the difference is just huge. Look at their nature. One is fundamental, the other is a result. Their range couldn't be more different. One goes on forever, the other barely exists outside the atom. And the cause? One is a straightforward interaction between charges. The other? It's a whole drama, a balance of several forces.
And just how short range are we talking about here? Look at this number, about 10 to the minus 10 meters. That's a 10 billionth of a meter. That distance is so small it's almost impossible to even picture, but in that tiny space, that's the entire universe for the forces holding an atom together.
So if you remember just one thing from all of this, let it be this right here. The electromagnetic force is fundamental. It's a basic building block. The atomic force is a resultant effect. It's what happens when you throw those building blocks, and others, into the crowded high-energy party that is an atom. One is the rule, the other is the outcome.
So let's just nail down that single, most crucial takeaway from this whole thing.
You know, the source material really puts it perfectly. The electromagnetic force is a fundamental, universal force. It's everywhere. The atomic force, though, is a resultant force that only happens inside atoms. It's a local phenomenon.
You know what? Maybe the best way to think about it is like this. The electromagnetic force, that's like flour or sugar. It's a basic fundamental ingredient. The atomic force, that's the cake. It's the complex, stable, and honestly beautiful thing you get when you mix all those ingredients together in just the right way under just the right conditions.
And that kind of just leaves you wondering, right? If something that seems so basic, so essential, like the force holding an atom together, is actually this complex mashup of other, more fundamental rules,